Rocky. Shh. So this is our warm-up for today. So we're still solving simultaneous equations without graphing. Last lesson, we looked at how to solve them using substitution method, right? For today, we will be looking at another algebraic method, which is what we call the elimination method. Okay, before we do that, let's have a look at our warm-up question here. And when you figure out the answer, can you please type it on the chat? All right, 70, is it 70? So Hale and Caitlin said it's 70. How did it become 70? Is it 25? So why do we have different answers? What do we need to do first? Right, let's figure out the drinks, each of the drinks cost. Type it on the chat, please. Each of the drinks cost $10, thank you. And therefore the burgers would also cost how much? Is it 2? 5. Yeah, so 10 and 5. So if this is 5, then the chips would have to be how much? $2, yes. So then we've got, this was 5, this is 2, and that's 10. So is it 70 or is it 25? Bit tricky this time. Yeah, it should be 25 because with BIDMAS, we remember to multiply first before we add, right? So then we've got, what's this, 2 times 10, that's 20, plus 5, you get 25. If you add these two first and then multiply by that, then you'll get a different answer. Okay, so this is a bit trickier than the previous one that we did. Okay, and these are sorry, and these are what applications of simultaneous equations, and you don't realize that it's on Facebook, and you know you are doing it. Okay, and it looks fun because maths is fun, really. All right, so let's have a look at solving simultaneous linear equations using elimination method. So the elimination method is one of those algebraic methods. Okay, so it is a method that you don't have to use graphing. Okay, you don't have to waste a lot of space in your book to graph and find out what the point of intersection is, but you'd be able to do it algebraically. Okay, now by its word, or by its term, or the name, it says elimination method. So what you need to do is to eliminate one of the variables. So when you have your simultaneous equations, it comes with more than one variable, right? And for you to be able to solve the equation, you want to end up with just one variable so that you'll be able to figure out what the value of that variable is. Okay, so when you've got two variables, your objective is to eliminate one of them. Okay, what do I mean? All right, so let's have a look at the example there. You've got negative 2x minus 3y equals negative 9. And then you've got 2x plus y equals 7. Now, just like when you're adding multi-digit numbers, you would want to have your terms with the x terms and the y terms aligned and the constants aligned together, all right? Because what you want to do is to either add or minus these equations for you to eliminate one of the variables, right? Now, for you to be able to eliminate one of them, we want to have opposites. And when you have opposites, if you've got a coefficient of -2, then the other one must be +2, because these are opposite integers, right? They're opposite each other on the number line from 0, right? So you can only cancel them. You would only be able to meet at 0 if they're of the same distance from 0. That's why they're opposite. So when you have a -2, the other one must be 2, right? This one, you've got -3. What's the coefficient of the other y term there? It's 1. So they are not opposites. So you would want to choose the ones that would have opposite coefficients, okay? So looking at this one, since they are opposites, then we can add them together, right? So that if we add these two terms, -2x plus 2x, that becomes 0. It zeroes out, right? So what we do with one term, we do with the rest of them, right? So we add -3y and y, we get -2y. Equals, what's -9 plus 7? That's equal to -2. Now we've eliminated the x term, we only have the y term. And that's what we want, because then we would be able to figure out what would be the value of y. -2 times something gives us -2. That something is 1, right? So that we say y is equal to 1. It's 1 because -2 times 1 gives you -2. Yes? So far, so good. Now, the same thing when we had the substitution method. Once we get one of the variables, then we can substitute that to one of our equations, right? So if I choose equation, so you can say that's equation 1, equation 2 here, right? Looking at these two equations here, because I don't want to be dealing with negative numbers, maybe you want to just use the ones with positive terms, okay? So regardless of which equation you choose, you should end up with the same value of x, okay? But choose the one that would probably be easier for you to use, okay? So I'll choose equation 2 because all of the terms are positive. So I'll write 2x plus y equals 7. And since I know that y equals 1, then I will just replace y with 1 and say 2x plus 1 gives me 7. And if 2x plus 1 is 7, something that I add to 1 gives me 7 is 6, and therefore 2x must be 6. If 2x is 6, what is the value of x then? X must be 3, right? Because 2 times 3 gives me 6. Just like all those things that you did here, replacing them. Okay, some may require guess and check, some may require a bit more algebraic, but this one you can just use your guess and check. Okay, so then you've got the values of y and x, and you just say the solution would be, you can write it as a ordered pair. So you can write it as 3, 1, or you can also write x equals 3 and y equals 1. So either way, right, would be good. I would actually prefer this because sometimes the simultaneous equations that you'll be given, you wouldn't have x and y, sometimes it's m and n, right? And it wouldn't be as usual as how we would be writing that into a number plane or a coordinate, okay? So that's one example. Now, sometimes they get more cruel than usual. Thanks, Joshua. More cruel than usual because then, you see, when I told you that you want, hang on, I'm just writing it down and I can't multitask apparently. See, that's falsehood. All right, so what I said a while ago was that you want to look at the coefficients wherein they've got opposites, but look at the coefficients of x and your coefficients of y. And none of them would be opposites of each other, right? So what do you need to do? Now, if you choose the y, you would want to multiply each of these terms. If you multiply a number to each of these terms, you don't change the value of, or the value of that equation. Okay, you just need to, you would probably just add on to it or multiply to it, right? So with this one, if you would choose a y, you would have to change the 5 and you would have to change the 3, right? But if you choose the x, this is already 2. So why don't you just make this as negative 2x, right? So if you make this as negative 2x, how do you make that as negative 2x? You would multiply it by negative 2. So you can only multiply it by a number, not adding by a number. You can also divide it, but it's not the usual way. It's more difficult. So just use the easier way, right? So we multiply this equation 1, multiply it by negative 2, right? So if I multiply that by negative 2, then my new equation becomes negative 2x. If I multiply negative 2 to negative 5y, I would get positive 10y. And if I multiply negative 2 to negative 17, I will get positive 34. Okay, so now I've got 3 equations, equation 1, equation 2, and equation 3, which is the same as equation 1, but then it's a multiplication of each of those terms by negative 2. Okay, so I did not change the value of that equation. I just renamed that equation so that it suits what I need to do with these equations. Okay, so now we can add these 2 equations because we've got this as negative 2 and that as negative 2. They are opposites. Okay, so if I add, that becomes 0. 3 plus 10y gives me 13y. And then 5 plus 34 gives me 39, right? 13y means 13 times y. What did I multiply to 13 to get 39? That's 3. So then I say y equals 3. Okay, now I've got a value for y. Now I've got 3 equations to choose from. I can choose equation 1, equation 2, or equation 3 to replace my value of y, right? But looking at all these equations, which one do you think I should use? Is it equation 1, 2, or 3? Remember, all 3 would give me the same value of x, but which one do you think would be an easier equation to use? It would have to be equation 1, right? Because then it looks simpler, right? So now I have x minus 5y equals negative 17, and x minus 5 times 3, because I replaced y with 3, equals negative 17. Now I've got x minus what's 5 times 3, that's 15, equals negative 17. And then I can add 15 to both sides. For me to find the value of x, I therefore would get x equals negative 2. Okay, so now you can write your solution as x equals negative 2 and y equals 3. Okay, yes. All right, now there's another example. As you may have guessed, there is no way for you to just multiply one of them, because then they're extra specially cruel this time, because what they want you to do would be to multiply both the equations by a number so that it would be common to both of them, right? So what we're looking at here would be your least common multiple, right? So you can change the y term. So we don't have to, actually, we can just choose x or y because they're equally difficult, right? But choosing between the two evils, 5 and 4 looks smaller than 6 and 5, so I might just choose the y term. So I would have to multiply the first equation by 4, and then multiply the second equation by 5. Okay, why did I choose the 4 and the 5? Because the least common multiple of 5 and 4 there are relatively prime, right? They don't have a common factor. And therefore, if I multiply 5 by 4, I get 20, and 4 by 5, I also get 20. And now I've got what? Coefficients that would be equal. And I did say that I want them opposites. So that would be an easy fix by making one of them negative. Okay, so if I put this as negative, right, then I would have my first equation as 6x times negative 4, I get negative 24x. If I've got 5y times negative 4, I get negative 20y. And then multiply 3 by negative 4, I get negative 12. Okay, and then multiply the first term by 5x, I get 25x, plus 4 times 5, I get 20y. And then I've got 2 times 5, I get 10. Okay, now I can add these equations. If I add the first terms, I have negative 24x plus 25x, which makes it perfect because I'm left with just one x, right? And this cancels out, and the last term becomes negative 12 plus 10, which gives me negative 2. And therefore, if I can just rewrite so they're side by side, then I can have x equals negative 2, right? Now from here, now we've got equation 3, equation 4 here. You might want to choose any of these. I'll just choose the first equation. So I'll have 6 multiplied by negative 2. Maybe I want to use brackets so I don't confuse myself with minus. And then you've got plus 5y equals 3. 6 times negative 2 is negative 12, plus 5y equals 3. Adding positive 12 to both sides, I will have 15. Why did I add 12 to both sides? Because then I want to cancel this, right? For me to cancel that, I need to add the opposite. So therefore, I've got 5y equals 15. 5 times something gives me 15. Y must be 3. Okay, and therefore you write solution x equals negative 2 and y equals 3. Okay, now I've got a video there which shows some, not easy, I think I forgot to just remove that because the last time I gave you was, it had 3 different ones, but this is a longer one. It would show you from easy to a more difficult one. So it would be good to just watch it as well if you need more examples. Otherwise, if you're confident that you'll be able to do the questions, then you're free to answer questions 1 to 4. Some of the questions would have heaps of questions to do, so just choose 4 of them. All right, so you'll be able to complete the task for today. And for the extension, there's questions 11 and 12 for you to do. Okay. Are there any questions so far? It's not very easy. You just need to be patient. If there are no questions, please start. For those who came in late, if you could, please make sure that you've completed the receipt of the assessment notification so that I can tick you off that. All right. Have a good day, everyone. I'll be staying online for your questions. See ya.
Come on, Rocky, let's go.